So far, we learned about the derivative function, and it's the slope of the original function. So if you have a function f of x, the slope of it is the derivative. But then the question is, what about that derivative function? Since it's its own function, can't it also have a slope function? And yes, it can. You can take the derivative of that and get what's called the second derivative of f, which is the first derivative of f prime. And then you can just keep taking these derivatives, so on and so forth. And like I said, the second derivative is the first derivative of f prime, but it's the second derivative of f. So the idea is, let me just give you a quick little example over here. If you have, let's just say y equals x to the third, then y prime is 3x squared. And you can take the derivative of that, and it becomes 6x. And then you can take the derivative of that, and it becomes 6. And then you can just keep this process going. And usually we just go down to the second derivative because there's some applications there. And I think the applications are posted right here. The main three we'd be using, like I said, would be the original, the position, distance, height, velocity, and acceleration. Third derivative is what's called the jerk. And then fourth derivative, it just keeps going on. Here's the notation, though. I wanted to give you the notation. So you have f prime, f double prime, f triple prime. And then sometimes I just use like a little 4 in parentheses instead of this. That's also possible. So here's what it looks like. Notice it's d squared y on the top, and on the bottom is dx squared. So just part of the notation there. So let's go ahead. Let's go through two examples. And like I said, I'll fill out these examples on the right. All right, so to start this, we're going to start with the first derivative. So f prime of x is going to equal to negative 2, because we got to take the derivative cosine. Times the, derivative of cosine is negative sine, so this should be negative 2 sine. Then times the derivative of the inside, which is just 1/2. And then 1/2 times the 2 just goes away, because 1/2 of 2 is just 2 over 2. And there you go. So this is the first derivative. But that's not what the question's asking for. It's asking for the second derivative. So now we're going to take the derivative of this function. So derivative of sine is just cosine, so we don't have to do the opposite there. And times the derivative of the inside. So we end up really right back with cosine, but negative 1/2 cosine of x over 2, that would be your answer. Let's take a look at this one. So this one's pretty easy. Different notation though. So I'm going to rewrite the original function so that we can use the power rule. So I'm going to write this as x 6 times x to the negative 2. Makes it a lot easier for us. So then when I do the first derivative, I'll just bring this over here. So when we do dy dx, it's just going to be negative 12 times x to the negative 3. Let's not change the form. I mean, we could put it in the denominator, but why do that? Because we have to take the derivative again. So when we take the second derivative, this will become 36x to the negative 4. And from there, they'll rewrite it. Put that x to the 4th back in the denominator. Remember, both of these are technically the same thing. Just multiple choice. They want to test you and see if you know how to change the form of it. And that's it. That's second derivatives. Pretty simple. Just take the first derivative and do the derivative again.